Okay, good morning, everyone. So welcome to the MBA 5106 Managing Information Systems course. And I'll be starting the course and I will give you first the introduction and then we will start the lectures scheduled for today. I hope you all got the note that I have uploaded to the LMS.
Yes, sir.
Thank you. Okay, I am Ajantha Atukorale. I am an undergraduate from University of Colombo. I did my first degree in computer science and also PhD in the same area. So I'm not from the management faculty, but I'm from the School of Computing. So I'll be talking more into the use of computing, and then Dr. Nuradi will be coming and taking over from me to continue the rest of the part of the course. So I'm at UCSA and currently the Deputy Director of the UCSA as well. And you can reach me through this email address, aja@ucsc.cmb.ac.lk. So second part will be done by Dr. Nuradi Jaisiri, who is from the Management of Faculty, Management of Finance and Department of, University of Colombo. So she will be taking over mostly the MIS part. I'll be doing the introduction to computing part. So the 5 lectures that I am planning to discuss with you all more into use of computing. So here I have named computer networks as the first topic. By the way, I know you all are not masters of computer science graduates or IT graduates. You all are MBA students, but you know that today IT is very, very important and it's part and parcel of your day-to-day work. So that's what we are looking at. So that when you say computer networks, I'm not going to teach you how computer networks works. And then the theory of computer networks, basically, even though I named it as networks because it's more into internet and then internet related business, like related internet issues, as well as virtualization and cloud computing. So that is what I'm going to discuss. So this will be a long lecture. Probably I will take about 1.5 days to cover that. So even though I said session 1, it will just maybe drag to the next day as well. The second topic I'm going to discuss with you all about software. Again, what we can do with software and importance of software and licensing. And then with that, we will be talking about open source and free software. And then with that, we can talk about competitive advantages and then how we can reduce the cost of investments when you are doing some work. So that is what we are more focusing on that. Again, not like how to develop software, or I'm not going to teach you any programming language or anything. The third topic that I'm going to discuss with you all is very important today. Information security, I have said. Again, not really the theory, but little bit of theory has to be discussed. Without that, you can't really understand what's going underneath. But however, especially when you're doing e-commerce, e-business, how we can do transaction over the internet, what really happens. And then when you do a transaction, so that how secure is that? And then we use like digital signatures, right? It's not like the manual signatures, how digital signatures can be used. And then digital certificates and maybe some security related issues as well will be discussed there. So that's more into practical side, focus towards business. But I would say here, a little bit of theory has to be covered in order to understand what is actually security, how we can really impose security on a network. The next topic I'm going to talk about neural networks. I have again named because today a lot of people talked about AI, MIS systems are there with a lot of AI and what is like how we can do and what we can do and what we can't do as well on a systems that suppose AI or fuzzy systems, right? So we will be looking at that, how to use AI or machine learning into a decision-making process. So what solutions and what are available. Finally, depending on the time that I said, depending on the time, because the first 4 lectures. So again, if you ask questions and the clarifications I will be giving. So however, I will try to discuss about new trends in computing so that certain things that are there. Again, I will be focusing not all new trends, but more towards the business, that how you can take competitive advantage and areas that you should be looking at, right, with your different backgrounds that you are coming up, right, to get again competitive advantage. So that's how I have made this syllabus. Actually, these content were coming from the past MBA students, because I'm doing this like bit of a long period now at the Faculty of Management. So that's certain things like students have asked questions. Based on that, I have included the content and discussed, right? So these are more like an MBA student required. That is what, and actually most of them are based on some other students after lectures, or like as well. Like unfortunately in this online mode, like interaction is very, very little. Yeah, try your best to keep good interaction. But when we have physical, so that people used to come and talk and then ask certain things, that based on that, I have really done this syllabus. So Dr. Nurazi will explain on the 6th day when she comes, like the MIS part that she is going to cover. So I'm not going to explain that, but these are the 5 topics she is going to cover. Again, the course-wise, this is how it goes on. So I'm doing the part 1, and Dr. Nuradi will be doing part 2. So 50% from part 1 and 50% from part 2. So again, from my 50%, only exam paper, you can get only 25%. So in a way, good or bad, right? But then 25% for presentations. So I'll be giving some topics for your groups, and then you will be making some presentations, and Dr. Nuradi and myself, mostly Dr. Nuradi will be evaluating from management point of view. That's what, like, I will be also helping you all to get your presentation done, right? I'm not going to do that, but I will be helping you all, but because I want from a management perspective to evaluate how good you have done that topic. But that those topics are more into IT, right? So technology or IT or ICT based things that you will be discussing. So that is what in the group presentations that you will be working on. So Dr. Nuradi's part is also like that, 25% from the exam paper. So she will be doing again another group activity. So she will explain that on the 6th week, right? That will be consist of 25%. From the exam paper point of view, you have to answer actually 4 questions, each again 25 marks each. Like if to make it 100, and out of that 50% will be taken. So I'll be giving 3 questions. You have to answer any 2. And similarly, Dr. Nuradi will be giving you 3 questions. You have to answer any 2. So I hope there's no issue. And this is going to be one of the easiest and easy to do subject, I guess, right? But of course, yes, you need that knowledge in the MIS and the computer use, right? And then you can do that. So I hope we will be doing that. So that's my part here. Like from the exam point of view, that is what the coverage, but to give you enough exposure and ideas like about IT, how we can use for business. So this is what like I'm doing that from computing background. Actually, I can't really nominate a book as this is the textbook I'm using, because as I told you initially, I have done this content based on the request that I have got from the past MBA students. That's what like I have put those things. So, but however, if you are really looking for books, like this is one of the textbooks, like just have, I couldn't really recently check whether this is the new edition is available on that, but this is one of the books. But like a lot of internet and the magazines, we can get like things that we discuss a lot. But Dr. Nuradi will be using a proper textbook, right? So she will be explaining, and then which chapters that she will be using for the course as well. So this is what the introduction to the course. But if you do have any questions, yes, you can ask. If not, like I will try to convert this to my other lecture note. But if you have any questions or concerns, or you can ask from now. If you're all silent, I assume that everything is okay and we can proceed in that way. Okay, so with that introduction, I'll be starting the first topic. As I told you, like I named it as computer networks, right? Then later on we'll discuss like different parts. Like when I have, so I have given you the notes on the LMS, and remember, like I have given the slide as it is, right? So there's no removal or anything. So the content as it is will be there per slide. So please don't use that for printing in case like if you're referring that. That's what like I have given pure black and white, removing all the backgrounds, right? With 2 pages per sheet for printing purpose. So you can use that for printing. So don't use this one because these days like color toner or like even toner usage, black and white, still you waste. So that's what I have given. But the slides, color ones are as slides. The printed ones is just for if you want to print it. That is what I have given. Okay. Yeah. So this is my first slide. And so with that, I would like to take some, so like if I do physical, I will come to you and ask some questions, but unfortunately, because of the online mode, right, I will try my best to not to spend more time like giving, like, but if you all are coming up, so please, you can come and ask or give answers. So if I ask what is the internet, right? So that is what we are looking at, what is the internet, and then how we can explain that. Internet, before coming internet, that's why like I would like to talk about a network, right? So if I ask what is a network, so there can be different kinds of networks, right? You might have heard about this, our power grid, right? This everyone knows about that power grid. That's a network actually. So we have the water, right? It is also coming in a network, right? Even our transportation is a network, right? So similarly, it goes several networks. So that when you just say networks, it doesn't mean like anything, like there are different. So that's why like we call computer networks, right? So computer networks are like if we have one computer, so if I just draw, this is my computer and this is maybe one person, right? So he or she can access this computer and do some work. So similarly, you can have several computers. And then let's say like this is your office environment, right? So these are 3 executives, right, working under you. So then they need computers. You have provided them the computers, right? And then let's say each of them are asking a printer. So this, I'll just draw a printer like this. So you can give them a printer, right? And then they will connect it to the computer and they can use it for printing purpose. But then can we have a common printer? I would put here NP, network printer, right? So that if these things can be connected somehow, right? So I'm not going to teach you like how these are being connected, like it's a bus network, star topology. So these are not your syllabus, right? So you will never get questions on that. By the way, as we go on, I will be telling what sort of questions you will be getting. And also like you can give some answers as well. So then I will say that, okay, that's a correct answer, or that is wrong. Or like if I can say like, okay, out of 100 marks, if I giving, like I will give you 50 marks or like that. So you can interact with me on that as well. And certain slides, when it comes, I will tell specifically like these are not for exam, because sometimes I have a slide into a lot of technical details because just to explain that, but from exam point of view, I'm not looking at. So that's why like here I just said, like I will not ask name 3 network topologies like star topology, bus topology. So that's what, if you have never heard about, don't worry about it. Right? If you know about that, that's okay. Just keep it up. But that's what, okay. So you can somehow connect these, right? So rather than giving these individual printers, we can have one network printer. So then easy to manage, right? One place, right? So of course they might have to walk because that might be in a different location, right? But still, as an organization, that will be good. So a computer network enables something, right? So if I ask, this is the main key thing. It share resources. Right? So actually computer networks are there to share resources. So the water network, power networks are for distribution and other things, right? But here, yes, this also distributes information from one computer to another, but still we call it sharing because you have a document here, right? You want to send it to a friend over the network because you don't want to put it to a USB drive or USB pen and then give it to him and then he will be putting back, right? But you can just on the network, you can transfer that. That's that we can say we can copy that, or whatever there are any method you can use. So that is still we say sharing of some resources. So computer networks are there to share resources. Okay, so that is what a computer network is basic. So if I ask in the exam, I can ask what is a computer network, right? It is a set of devices that is enable you to share resources, right? That will be okay, right? You don't need to say need to have a switch or a router, right? And then you have to connect them this particular topology, right? You don't need that, because I just want to know, like, okay, you have a good understanding about what a computer network is. So like what is the main importance of like having a network, right? So computer network, so then you can say share resources. There are other things as well. You can have other minor things, but you can get this is the main important one. Right, so then just giving that understanding of what a computer network is. So now if I come back and ask what is the internet or what is internet, right? It's something like this. So just I'll draw a network like this. This is like earlier I was just drawing some 3 computers with some connectivity. Just assume now I can just put it like any shape, right? So don't want like, so do you have to put a network like this, a cloud kind of, the cloud is something separately, right? We will discuss that later, probably not today, next week. But yeah, I can just do, these are all computer networks, right? Just assume these blocks, circles, squares, whatever shape, right? So this is, I would say, network 1. Just, I will try to make it as short letter so that easy for me to write. So this is network 3. So these are 3 independent networks, right? So then these 3 networks also can be networked. So now this is like putting, right, the same topology, assuming each network is just an individual machine, right? So that means I can connect this with that or with this. Someone can ask, do you have to connect like this as well? Yeah, there are different ways of connectivity. Again, I said, so this is more technical stuff, but yeah, just either these A and B lines are enough to make it networked, or A, B, C, right? 3 lines are okay to connect, right? That's how we can do like maximum number of connections that you can have. So these 3 networks, right? When we interconnect like this, that we call, this is an internet, because interconnected networks, right? So there's the word internet is coming from that, right? Internet, right? Interconnected networks. So it's basically, if I ask what is internet, don't tell me this is what like we get our connectivity, or this is how I go to our LMS and access node, right? But that's like, that's a different thing. We will discuss that, right, in detail. But basically internet is an interconnected network, right? So this is an internet, right? So there is no web pages here, right? There's no e-commerce here, right? So that it has to build on top of that later on, right? But this is the internet. So internet is interconnected networks. So it's similar to a net. This is also another network. So if I ask, is an internet a network? The answer is yes, right? So that's why, like, so let's say in the exam, if I ask, is an internet, is a, can I say like this? The internet is a network. Is either statement true or false, right? These kind of questions. So you can, if you say in the exam, yes, right? I will not give marks, because just anyone can say yes or no, right? This is a pure guess, right? But then you have to justify, right? Again, of course, I will write in the question paper, justify your answer, right? If you don't justify, you won't get marks, right? You have to justify why it is yes, because this is interconnected network, right? It is also network, right? We can see if we take each individual networks as machines or devices, then this is another network. But however, someone can say no, right? Okay, let's say I will try to explain that also, because some of the questions I ask in the exam also no definite true false, right? You can say no, internet is not a network, right? But then you have to say it is interconnected of, like, it's not one network, it is like interconnection of so many networks. But then I can say like, okay, you try to explain the same thing in a different way, but still you have a valid reason, right? So that's why, like, so if you justify that, but don't think that each and every question like that you can justify yes or no and go ahead. But yeah, so this in particular this question, right? You can say no, it is not a one network, right? It is kind of a connected, but actually it's a one network, right? So I will come there. But even if you give that, okay, I can say our justification seems all right. So I can give you marks, right? But definitely there are some questions you can't say no, like it is wrong answer. Then if you try to justify whatever the way, you will not get marks. But yeah, so there can be some doubtful like a statement. So then the way you justify that, you can make it a point, right? Okay, so internet is an interconnected network. So then that is what internet is. Now I will put another question here. So I prefer, this is actually, I get a vote generally, but I didn't try to put it here because it takes a bit more time. But I'll write this thing as two words, like maybe if you all can interact with me, just open your mic and then give me, right? So there I have write two words. So these are words, right? Internet with simple I, internet with capital I. Does this have any meaning here, or is it the same, or is different? This is, I think I have asked in an exam as well, right? So I've given these two names, right? Terms, right? Are these same or different? If so, you justify. Any answers like would like to take? A and B are same or not? I can ask, are they same? You can take it, that's all right. This was like a, if I come closer to you, you will have to give an answer. Unfortunately, we are a bit of a longer distance, right? Because of that, I think most people try to keep quiet. So here, from computing perspective, right? Yeah, it's not the same. There's a slight difference, but of course, some people do use this interchangeably, right? But there is a bit of a meaning on that. What we say is the word internet. This is a generic term that we use, like, so it's interconnected networks again. Same thing, both are using interconnected networks. Remember, when we have these networks, right? So all the networks, right? We can interconnect like this. So let's say we are living on Earth. This is our world, right? So on Earth, like all the networks that are there, whatever, right? And then this has been interconnected as one network, right? So this is what we call, that's what we use the internet, the article the, right? So the internet means there's only one, right? So that is only one network like that. That is a bigger network, right? So that's what, like, even in the previous question, when I said justification as no, that is in a way wrong, because this with capital I internet, when we refer, that is, we refer the biggest one. So that's where, like, you will try to connect now through Zoom to access this lecture, or like to listen to this lecture, or to read what's happening today, right? Whatever you do on the internet, or you did a transaction, right? You try to buy something with using your credit card. So all these that you use this particular internet, so that we normally call the main thing, like the biggest network on Earth, right? Because I said on Earth means that is what we all can access, because we don't know whether Jupiter or Mars will have their own networks, right? But we know, like, on Earth, that is the biggest one. So whenever you refer even inside a paragraph, so I'll write it like that, my paragraph. So you can just write internet, blah, 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 right? So that, because you refer that internet, right? So when you get connected to internet, you can get so and so, so this, right? So it's like some people say, like, when I can remember when I was asking this question in a physical class, someone said, like, whenever starting a sentence, I use this B, inside a sentence, I use A, right? I can remember someone said, B is a noun, A is a verb. So that's why, like, so different answers were given. But main usage in computing, with capital I, we refer that internet. So if you refer, you have to connect to internet and do whatever, right? So then you can refer that. So this is a generic term. That's why, like, because of that, we use another term similar to this. We call intranet. That is like a kind of this network connected, but it's a local one, right? I would say like Mars Holdings, right, or Haley's. So they will be having their own, let's say, network, right? So this is, they are all machines, like all interconnected, but let's say they are not connected to the internet, right? For, let's assume not, right? So then this can be a smaller internet, right? So then we can say that is an internet, because not the internet, it's an internet. But of course you can, that's why like for easy representation, we call intranet, right? So intranet is a local network. So this is just say the local like it's a not, this is, I would say, global, right? So that's the difference between the two terms, the internet, right? With capital I and simple I. So whenever you refer now hereafter, right? Since when you're doing presentations, right? So please make sure that you use the right term there. If not, like I will be a bit I would say like strict on that, and because when marking, right? So because you have to refer the right term once we discuss that. But of course, if you have used up to now throughout like interchangeably, that's, don't worry. That's not a big issue. That in certain cases says like people will understand, but however, it's better to make it very clear. Right. So that's now we have some understanding about what is internet, right? So then I will try to get my first bullet on the note. It says the largest or the biggest network of networks of the world, or that's what I said earlier, Earth, right? So whatever, right? Whatever we know, right? So the largest one network. So that's like we have only one. So remember, this is the most important thing. There's only one network as such, not many, right? So that's how that we can say what it's. So it's just like this. Like you can say this is just, if you take, this is the whole Earth that we are talking about, right? And then all the countries are being somehow, you can say, is interconnected, right? We'll talk about like how they have been really interconnected as well later. But then you can share resources from this particular location to this location. There's no issue, right? Through that network, it can be accessed, right? So that is the internet. And it uses, okay, I'll just try to clear that. It says it uses TCP/IP protocol. Okay, first of all, don't worry about this. This is just a name, right? For you all, it's a name. So the name means what? Like, okay, maybe George Bush, right? Or like Ajantha, or like whatever the name, right? So Sri Lanka, right? It's like that. It's a TCP/IP is a name for you all, right? Of course, I will tell what it is a little bit later, right, on a slide, but we are not going to study about TCP/IP. That's what I'm not going to teach you that as well. If you all want to really understand that, maybe later on after the MBA, you can do a master at UCSC, so we will teach that as well. But yeah, TCP/IP is just for you all a name, right? But I want to explain this. What is this? What is a protocol, right? So a protocol is a set of rules that we can understand, right? So, but let's say like if I now start explaining you, let's say for some reason I know Chinese or French, right? And if I try to explain certain things using that language, you all can you can't understand, given that you don't know there are those two languages, assume, right? So then there won't be a communication happen between two of us. So similarly, to have a network share resources, how can we have without a common language? So this is, I would say, a common language. To tell you another example, so I was just earlier telling you this is a computer, right? This is another computer, right? But then this connects to a printer, right? So now you just send a document, right? It's 10 pages. And then you want to say single side, right? And then use black and white. But then what if like this prints in double side, right? In a color, right? And also like it just, you said here portrait, here it will be using non-portrait, right? So then landscape. So then not that exact instruction that you have given, the printer has done that work. So that's why like we need a common language. So this is what a common language is required. So that is what through a protocol only we can do that. So in computing, we call it a protocol. So now the protocol name is TCP/IP. So TCP/IP is a common protocol, right? Common language. Now it's a common protocol for any network-based connections to happen, right? So if not, like you have to have, now remember this printer is kind of a hardware. Your computer is also hardware. I will tell like my second lecture when I start, right? A hardware cannot do anything. It's a dumb device, right? It's just hardware. It's just some hardware, right? So without having software, you can't really make something useful. So this is what we are doing. So we are putting a common software, right, which is we call a common protocol to communicate each other and then try to do our work, right? So if I ask what is TCP/IP protocol in the exam paper, so you are not trying to explain what is TCP/IP or how it works, right? So it's a common language because then only this any network-based device can communicate with another network-based device to do a task, right? Do a given task. So that is one. So a protocol is a software that tries to help us this hardware to operate, right? So if these two are different languages that it cannot understand, so then there's going to be a issue, right? So they will not understand. So I will now take a small case study as well. That's like you all are mostly decision makers, right? So like I am looking at, right? So this is your table, right? So you will be sitting here. So you are the guy, the big boss, or like it can be CIO, CEO, like other financial chief, right? But that doesn't matter, but you have to make some decisions, right? So these lot of proposals are coming. So you are the one who is going to make that decision, right? But don't say that when IT matters comes, I'm just running away. No, you can't, right? Because today you can't do that. So it's where like we are trying to understand, where I'm trying to explain to you all as well. Let's say like I am now not a lecturer, let's say I'm a sales guy, right? I am coming here and you all are trying to buy some network printer, right? And then I'd say like, okay, so let's say I will take HP is also have come to you all, like their proposal is, let's say 2 million, right? So let's say that proposal for that particular printer, just assume, right? So it can be today's context, the prices are going so up, but I'm not saying a printer is not 2 million, just for understanding. So I am as a sales guy, so I will say AP, Ajantha's printer, right? So that printer, I would say it's about like 1 million, right? So it's very good, right? It's cheap, right? It's half price, right? So then I'm saying, I also do have a printer rather than HP. So our ones are, my one is 1 million, right? So then of course, then, you know, other technical things are, you have to look into like per toner, like how many yield that you are going to get, how many printouts you are going to print, like let's say X number, this is also X number. And then you said like, okay, now I want to check the once we buy the printer, right? What is the price per page or rupees per page I have to spend. This is Y. Similarly, this is Y. That's okay now. All are comparative. Let's say this all figures when you are doing in a technical context, right? Maybe your IT guy here, right, has given you the report saying that these two printers technically almost similar with respect to the parameters you have given, sir. And then I can say, so this is what. But then you can ask, so what is the protocol that it uses? Because it's a network printer. So let's say this HP printer is a standard one, so it uses TCP/IP, right? But this is, yes, we are using our own proprietary protocol called Colombo, I would say. Right? It's a name, right? Colombo, right? Okay. So then, but still it works. There's no issue, right? I can say as a sales guy. But now you can ask, next question is, okay, this is the printer. So this is one user. So now to communicate, you have to put the software. So this Colombo, whatever proprietary protocol I had to install right here, right? They will say when you buy, you get one free protocol update onto a computer. But then next, there are hundreds or thousands of computers you have, right? So all are going to be used this particular printer. This is as well like millions rupees. But then you have to buy the license for each of them later on, because then only it will work, because this is not common. Now you can see, even though your comparisons were very good in the money wise, like this is cheaper, but maybe long run, like when you try to use more and more, right? And then let's say this license also given per year, you have to upgrade that, right? So then you can see you are really caught up. Maybe probably later on you might be spending about 2.5 million rupees, right, after 1 year. But if you just spent, like, you would have used only 2 million. So that's just a simple example. I'm just trying to show you like the importance of TCP/IP. So that is the common language. So whenever you buy any network device, it has to be TCP/IP, right? So just pretend that you know what is TCP/IP and ask, is it TCP/IP compatible, or like, is it a TCP/IP protocol device, right? If it is so, then from network point of view, I would say that will be all right. So, but again, you have to evaluate a product like with the other parameters, whether that is giving you a better outcome, right? But if it is not, right, then you have to be careful, because you might be caught up with this. So that's why, like, I will not talk much about the software issues here, because I have a separate lecture on software, right? That's where, like, in business point of view, I want to talk with you all with respect to licensing as well. But here, that indication is there, like you have to be very careful. So TCP/IP is a common protocol that uses on our network, or whenever we use internet-based any resource, right? So today, let's say you are going to buy a projector, right? So that projector is also, you want to access from some other place, because you put a note there or presentations, and then come and do the presentation later on the projector. So it's a network thing, right? So then you have to make sure that they are using the common protocol. So don't try to use any proprietary protocol, because you can get caught up with especially the licensing. So I hope now you have an understanding about what TCP/IP, but as I said, don't try to understand what TCP. Going to do that internally. So internet today is a widespread information infrastructure. Okay, I will try to explain that term as well. Now, just think, okay, I will just draw some circles here. So here, this is not now networks. These are, just assume these are cities, right? Right. So this is just how it's connected. This is a network kind of, right? You can have other connections as well, but just keep it like that. So these are the cities, right? So whenever you have, these are the roads that connects from city to city. So this is a road, right? So this is not a complete network, by the way. We'll come to there. So then we have a nice road infrastructure. Right, infrastructure to do, you all are all into entrepreneurs, you want to do a business, right? So Colombo, Kennedy, Jaffna, Mathura, all are connected, which is a very nice network is there. Let's say highways are done. So then you can think of, like, you can start anywhere, right? Your business, right? There's no issue, right? Because the road infrastructure is there. But given the road infrastructure, can you do the business? No. Like, in order to take your products from one place to another, you need, right, vehicles, right? So these are the vehicles that will be running on this, right? And then trying to carry your data from one place to another. So that from A to B, right, to travel, so that you put your data or your whatever goods, I would say, right, into this, and then it has to go through. So similarly, internet is like this road infrastructure. Internet or intranet, right? Whatever, right? So internet is in the global scale, and the local scale, it can be intranet, is a road infrastructure. It can't do much. So then to do something, you have to send some file, because now we're not goods really, right? You can't send really goods over the network, internet network, right? Only like you can send information or data, right? So the data can be sent from A to B. So then you need something like vehicles. So what are those vehicles? These are what we call applications, right? So you need some applications, right? So for example, web is an application. So through a web page you can do, right? or like now there's another application called Zoom that if I want to do a remote lecture, which I'm doing now, right? Because let's say I am at B, you all are at, one of you at A. So to reach me, right, and connect my lecture live now, right? So you have to have infrastructures. That's what, without connecting to internet, you can't get this. But just so sake of connected internet, you won't get my lecture. That's why like you have to get the URL and then access through Zoom, right? Then only you can get it. So that is where the application is supporting. So it can be a web-based thing, or it can be a separate application. Like maybe you are playing a game, right? Network game. So then one opponent is here. So you are here. So then through the game app, you will be connected. So that is what all about. So actually internet is an infrastructure. Right? So remember, it's just, that's why like earlier I said, like when you have internet, it's not everything is there, right? So internet is just giving you the connectivity. So you can say I'm now on the internet, but so what? You can't do much, right? You are just connected, that's all. But to do some work, right, you need some applications, right? And then you have to work with those, or do with those applications to get your work done, right? I will discuss those things later, right? That's why like, so this is first my first slide, just try to explain you the internet, so that giving you the right picture. So now coming back, so with these 3 bullets, internet means it's the largest of networks, right, on earth, which uses a common protocol called TCP/IP, and it is actually an infrastructure which provide us or facilitates us to do certain activities, right, by using applications, right? So that is what internet is. So the next, this part of the slide is just not for the exam. This is like if you really want to read more about internet, like who started and how, right? So just type this term on the Google, right? Brief history of the internet. So these are the, we call fathers of the internet. So Winston Cerf, Robert Kahn, and so many other people. So they are the people who invented this, right? We will talk about that also a little bit, how they have done this, right? Yeah, so this is a research paper, right? Maybe you all can download and maybe read that. But however, nothing will be coming from that itself for the exam, right? But for the knowledge, that will be. And also coming back to these 3 points, like let's say if I ask in the exam, what is internet, right? And if you put these 3 bullets, and if I supposed to give 100 marks, I probably give about 30, right? So you will see like what is going on here, right? That is because I'm not 100% sure whether you really understood what is internet to just you, right? Just by heart this and then reproduce that, right? Like the Girava, right? So then that is what I don't want to give you even 50, right? So that's why I said don't use my slide as it is in the exam paper, right? So you make it your right understanding and try to show that. So then while doing that, maybe a little bit some mistakes will be done, that will be accepted, right? As long as you have got the understanding. So that's what, so don't repeat my notes straight away in the exam, right? Because I'm not 100% sure whether you have understood that is what you are. So just you can make it, right? So that's what I just tried to, I took some time to explain what is internet. And so given you like a background onto that, and then explain certain things, because without having a so this term common, I have not put, it's very important keyword, right? But that's just when you say TCP/IP, that's what we say, it's a common, but from on your context, right? When you explain, it has to be a common protocol has to be there. Then not like everyone can be use that, right? The largest one, as well as that is an infrastructure, right? These are the key things, right? That you should be aware of. What is internet? There are so many other things you can tell, but so these what I would say in simple terms to explain what is internet. So with that, I can say, so the internet and yeah, this is World Wide Web. That's another good thing, right? I have another slide later on. Again, I can say my A would be internet and my B would be web, or same thing, www, World Wide Web, right? So if I ask, are these 2 things same? right? I hope now you might be able to understand and tell that it is not same, because I told this is an infrastructure. This is an example of an application which runs on that, right? So they are not the same, right? Because infrastructure is provided and then the web will be doing the application, right? So there are two things, right? So always to understand that. And just clear up this. Okay. Here, what I'm showing here is, yeah, this is like the TCP. This is the network, right? This is, I would say, the network or the internet. You don't need to write always like a cloud ray, right? Just we used to do like that, right? So that is the internet. That's the infrastructure now, right? So now let's say this is you, right? You want to download my note, right? From the LMS in the management faculty, right? So what you do is you have to have a client program, right? Because the server is also has to be running. So that's where like my note, okay. My note will be inside here. So this is that note, right? That's where like server is keeping that. So what you do is from this program, you make a request. Please give me that. That's a request. Like you have, we'll talk about URLs later. Like this is just URL for Columbia University, not the management faculty, right? Just as request will be coming over the network, right, to the server. That's where like the internet is going to facilitate, right? And then that request will be asking my note, right, MBA 5106, right, lecture 1. So then that will be added to a request and then send back that, sorry, it will be going back as a response, right, reply, right? Then only you get my note, which actually the note will be here inside the computer. That's where like you will be now open with whatever PDF, right, editor, and start reading on that. So the file was here, a copy of that was given to you. That's why like it takes time. That's what you have to spend some money, because it takes some data, right? Because this is the request is just no file. Actually, you just make a request, right? That's what this is. It's like empty boxes coming with a request. Give me that, right? Rather than say empty, I would say there is a question or something will be there on that box, right? Which is not very loaded, right? Just a small request saying that I need that. But when that box is going up, that is but heavily loaded, because that is my page, right? With all images and everything. That's where like depending on the megabytes or the gigabyte, you know how long it will take. And that's where like you might have to pay for that, right? Based on that. Because that you are using the infrastructure for that, right? So infrastructure is not free. You have to actually pay as well, right? Because that's where like your internet charges are coming up as well. So this is like the whole scenario that we discussed with internet and web, right? So always a client will be making the request from a server. So there can be so many clients, right? So thousands or hundreds of clients can be handled by the server. That's where like load it, right? So if more requests are coming, we have to increase the load of the server as well. So this is a very simple example, right? So the Department of Examinations, when the results are released, you know the server is down because so many unprecedented number of requests are coming. Everyone was trying to check their results, and then the server cannot handle, right? That's like different story. Like we'll talk about that when it comes to cloud computing, like how we can manage that. But basically, if you are just talking about in this simple context, right? So the server has to be capable of handling the client base. So this is where like it's important thing, because this is where like you all should understand as well, right? Decision makers from the top level, right? Where like you have a web server, like if you see that a lot of complaints are there, the clients are saying that your server is very difficult to access. Most of the time it is down. Then when you check with your IT department, they say, no, the server was up and running. There's no issue, but that's right. But issue is there with your business, right? This is where like you have to now make a decision, right? So increase the capacity of this, or increase the bandwidth of the network, right? So then you know that you can cater more clients and get your business done well, right? So that's where like to take the right decisions, right? You have to be aware of these things. If not, like you will just listen to what some dumb IT guy who is in your department says, right? And just they don't want to make much work, right? So there's this is everything is all right. But then when you know that, you can take right action. Okay, so this is a small definition what a protocol is, which we have discussed. I think what a browser is, right? To tell you, right, some of the exam papers, if you look at past papers, I have asked, write down 5 browsers, internet browsers, right? So that I don't think that such simple question you will be getting, but I have done myself, like just to make sure that you all are so comfortable, right? But sometimes I just give in the note only 3, and then I ask in the exam, write down 5, right? And that's where like I said, okay, you should be knowing it. Like most of the people might be using either IE or Chrome, right? Or Firefox. There are a few other types as well. So people who are using Apple computers, you will be using different browsers. So maybe knowing about several, that will be not bad, right? And also like then you have some experience as well, because sometimes some of the content when you try to access from one browser, right, it is not really optimized for that. So we'll talk about that, this optimization thing as well. But just for like, then you can try another browser and see whether, because someone was telling that he was able to access that, but then when you try to access, it is not working like the way that your friend is telling. So then maybe probably there might be a problem with the browser. So why not I try another browser, right? So that is what here, the main point. But this slide is just basically we have discussed. Now I'm trying to talk about like, let's go and look at some flashback of how, so still I'm on the topic of internet, right? We are trying to go a little bit deeper and deeper and try to understand the internet, which relates to business. But so this is a bit of history side. Internet was starting as a project, right? Which is under Department of Defense of USA, right? So it's a project. It's a classified project, by the way, because of the Russians were running Sputnik, and they were quite good. Not like today the Russians are doing certain things, but however in 1950s, like mid 50s, like Russians were way up, right? So that's why like US was so scared of them, right? But I think now they have sort of different ball game they have. But this time period, they were so scared. So because of that, they were trying to protect. So this is, as I said, it's a classified project. So under Department of Defense, right? No one knows, like maybe later on only we got to know. So they were just having the same thing that we've discussed just a few minutes ago. So they wanted to have a network connected each other, right? So that if something happens to one of these cities, right, still they can manage, right, and then do the rest of the work, right? That's where like they were trying to connect a network of networks, right? At that time, no term internet was there, right? So this is before the birth of the word internet, right? So then they were using a network of network concept, right? So they were trying to get, they thought like, then that's the best way to like do the business, right? Or do the even the politically as well as from business point of view, right? Do their things right well when things are maybe got damaged or whatever. So that project was there, but you know, like Russians were defeated in different ways, like not this way, right? So this particular project, who worked? So again, if I go back like a few slides, like can you remember I've asked you to read a research paper? So those, some of the names are the guys who really worked on this classified project, right? So they were, some were professors from universities, some were from the industry. So they all worked here for this particular project. So then it was there in like throughout like 10, 12 years, but never used, right? So this particular network was never used, not used. So then some of the professors actually in 1969, actually 4 professors, or like 4 universities, by the way: Stanford, University of California, Los Angeles, University of California, Santa Barbara, and then University of Utah. So these are the 4 universities, like in the US, and then 4 different locations, right? And they said, okay, let's try to, we have already now this connected network, right? Because we have this classified project which we worked, right? So those people might be from those universities. And then they said, okay, let's try to, since the government is also not using that, let's try to transfer some files, right? Transfer some file, that is like transfer some data from one place to another, right? So that's what like they said. So they came up with a nice protocol, that is they call file transfer protocol, and we call that as FTP, right? I think some of you all might have heard about that, right? So FTP is nothing but, right? I'm going to teach you like FTP. We never now use that. It's a pretty old one, but it's very simple. Still, we do that because through web, when you download a MP3 file or some file from YouTube, the same thing, you're doing that, right? File transfer protocol, but you do it in a different way now. But that's what they wanted to have. Just to transfer a file. So they said we had only 4 computers starting with. So this is the start of the internet, right? Still the word didn't call internet at that time. So then these 4 people were shown that yes, we can use it for, now again, not for commercial purpose at this time period, not yet, right? So they said for research work, we can use this because they were transferring some important files that they can do research, right? This is more academically, right, as this time. So then the Department of Defense also is interested, and they said, okay, they connected a few more computers and make it a new name, right? Again, still not internet. They call ARPANET because the project was called ARPA, Advanced Research Project Agency, and then ARPANET, that's what the name given. And then that was running. So then, so now people will start doing some, mostly universities were connected initially. Because they were to do some research work, right? So, and then the US guys wants to connect some international partners as well. So then the first 2 international partners is University of College London, UCL, what we call, right? And then the Royal Radar Establishment in Norway, right? That's another sort of like defense-related organization. So UCL and then this Norway, right, are the 2 international bodies. So they connected. So people were using, and then something called Useness. And again, we don't use now, right? Again, by the way, for the exam, I don't ask when was Useness established, right? You will never get a question like that, right? So just these few slides are there for you to give you an idea, right? But knowing about certain time period, what has happened when started with 4 computers, and it's just get on, like, but I will not very specifically ask, right? Even though it's in my note. So it went on like that. You can see this is the important era, right? Even though 1969 everything started, right? After several years, they came up with this name TCP/IP, right? So this is where like the word later on internet is also came, right? So it was like TCP/IP was introduced in 1982, right? Not that very long time back, right? But even 1969, it started that whole work. But you can see later on, like the ARPANET term was deactivated. That's because more into defense, right? Because they want to get more and more people. You can see now it is increasing, 1,000 computers, right, worldwide. People were using, but very low speed. That's what today 64 kbps means. Whenever your internet bandwidth is finished, your ISPs never close your internet bandwidth, right? They just put you to 64 kbps. But then everyone says that, okay, my internet quota is over and now it is not working. Actually, it's not working, it's working, right? But only thing is, with this speed, you can't do much, right? But if you're doing like simple file transfers or whatever, you can do that because that is more than enough to that work, right? So the ISPs are not so bad, like whenever your quota is over, they don't cut you completely, just drop you from whatever 10 Mbps to this 64 kbps, right? By the way, this is K, right? So that's a very slow speed. But that is what, like below that is what the backbone was running, right? So that's what, like we were talking about how internet is 1990s, right? But this is another important year. Sorry. Important here, that is 1991. This is when the World Wide Web, right, what we call the web was invented, right? So it was invented by a guy called Tim Berners-Lee. Tim Berners-Lee, right? He was from CERN. He's from European, like from Netherlands. He was working there, right? He's kind of a physicist, right? He's not a computer scientist, but having good computing knowledge. So he is the one who proposed this model. Okay, since we have the internet now, right? The infrastructure is there. So why not we have something, server is put with some pages, that is web pages, right? And then say a client can access through this network that page and get it back, and then we can show that in the browser. So then we can create another software called a web browser, right? So then from the web server, it reads and shows that. That's where like people started. So if someone says we were using the web, right, in 1970s, right, that's wrong, right? So then they're not doing the right thing, because it was invented in 1991, right? If you really look here, the history, the Sri Lanka, I think SLT, the guys who are here in SLT can tell, right? SLT also connected to internet in 1991, to my knowledge, right? If it is wrong, you can update me or tell. So according to my knowledge, SLT in Sri Lanka also connected to internet in 1991. So that's where like that year where the web was there as well. So that on that, so I don't know like whether people really use the web in a very extensive way, but it's very, very limited way, but only some universities, right? Some big organizations have connectivity, right? It's very elementary level also that we had, but you can see that thousands becomes millions, right? The next year, right? So that's why like World Wide Web is kind of a, we call killer application. It doesn't mean it's not going to kill you, right? But kind of like some people nowadays, based on the way you behave on the internet or the web, right? So can be a killer, but this is what we call killer application. Means it's just like blasted, like in a way, like people were just coming into a new world, right? That's where like 1991, 1992 is a period that they are talking about, right? So these things I'm not interested to talk or check in the exam. Just put your for your easiness, like just a completeness, right? So that's what something happens, right? But I don't want to explain to you. But web traffic was very low at that time, it's just about 1%, right? But as of today, right, of like 7.9 billion, like close to 8 billion people, we have 5.2 billion users, right? So currently the statistics is 5.2 billion, right? You can say 1992, 1 million, now is 5.2 billion, right? So that's like huge number. This is how it's been transformed. But from 1969 to 1991 to 2022, right? You can see what has happened, and then the internet has done a lot, right? But remember, internet is an infrastructure, right? But it's not an application. Just give me 1 minute. So just pause it. Okay, yeah. So that's how today it's propagated. So you can see the transformations, right? From 1969 to 1982, where TCP/IP came, to 1991, where web came. So this is where TCP/IP. This is where the concept, and this is where like web application came, right? A little bit like, because then someone can say like, are we without any application? No. If FTP is an application, there's another one called Telnet, remotely login, right? So there are quite a few applications, but this is what I said, it's a killer application. Means it's just basically like everyone is using now that as an application. But now we are in 2022, right? So this is what like we are. So now Asia is the most number of users we have, like close to 3 billion now, right? But rest of the people, you can see like the population. So this is like internet penetration. So if you want to see this, or later on, if you want to use, this is one place you can get, right? www.internetworldstats.com, right? This is where like I have also taken this right? So here put the URL for you all to also to get some information if you are looking for. And there are a lot of data statistics are there. So here also just I want to show you again, not from exam point of view, like Asia in 2009, it's about 20% penetration level. So how it has been improved over an years, right? Sorry, that's the wrong one. Asia is here, right? That is 2020, right? But still world average, we are just Asians are little bit like behind the world average, right? As of 2020, right? Q3, I couldn't find the new one, right? So probably when you go to that website, you can get maybe probably 2021 or 2022 statistics might be there. So you can see still Asia as a region is behind the world average or not, right? But then let's look at our country. Where are we, right? So as we have 22, close to 22 million population, we have about, according to them, 7.9 million users as of 2021 June. This is like recently also when I checked, they have not updated this in 2022 yet, or 2021 December. They have 2021 June, 7.9 million, which is about 37% penetration, right? Which I just go back one slide. This is where like we are talking about 59 or 63 is the world and the Asian average, right? Where we are very much behind as a country. So that's where like it's also very important, like as of today's context, the country situation, it's very difficult to do things to make it, but I think we need, right, to improve that. According to them, we have about 7.9 million Facebook accounts, right? Sri Lankans, right? So that means like almost all of you all in this class probably might be having. So if one or two is not having, so that means you are not in the 7.9. But yeah, so like Facebook accounts to this, I think looks like they have given similar statistics, right? So that's where like maybe when you look at it, other countries, like probably they might not be able to get this data, right? That is what this number. So looks like this number is coming from here, right? So where can we get the statistics, real statistics, right, of Sri Lanka? So either TRCSL, Telecom Regulatory Commission of Sri Lanka, or Census and Statistics, right, of Sri Lanka should be able. Other than that, I would say maybe Central Bank of Sri Lanka should be able to get with their reports, as well as there's another agency called ICT agency, so they might be having. But unfortunately, as you all know, right? So if I say 1, 2, 3, and 4 entities, if you really ask, if you do a questionnaire, right, you might get 4 different answers. That's a bit bad, right? So we have to do a proper, I think Census and Statistics is the one who should do a proper survey statistics, like which I think they have not supposed to do 2020 survey, but they couldn't do due to Corona, I guess. But if they can collect the information real, right, how many really have people computers, how many people have connected to the internet, right? So that will be good to see that number, right? I have seen different figures than this number, right? They are quoting in different places, but however, I am also not sure, 100% sure about that, right? So if you're one of those people who have some power authority, right, maybe you can try to do that and see where we are. But looks like we are behind much, right? Because to 30s to 60s, like it's a huge ask, right? But so this was the situation. But again, if you look in some countries, like for example, do I have Vietnam? Yeah, Vietnam is a good place to look at, right? Because it's with that population, right? Where like we are looking at, so they are talking about 70s, right? So that's a big number, right? And also like look at Bangladesh, right? So with that numbers, so where they are. So then that tells also like where we are as a country. Now this is a picture that you can, I think this is not very clear even if you try to print it. So don't try to print this page. Even I have put here a bit of an older one. Now you can type on Google submarine cable map 2022, right? So then you can get the latest one. It's like a big high resolution image. You can later on then zoom out and see like, so these are all we call fiber optic cables. Connecting each other. So what is that? That is the infrastructure. That is the internet, right? So actually internet is this. So then someone can ask, you said fiber optic cables. Can't you use other things like, can you use Wi-Fi here? The answer is no. Wi-Fi is just about like 100 meters. We are talking about this from, I think, Colombo to Singapore. It's about like, Singapore is somewhere down here. It's about like, I think 3,000 kilometers, right? You can't really, right? Just Wi-Fi is just a local proximity solution to provide internet. So can you have then radio links, right? Yes, can go up, let's say 100, I would say 100 kilometers. Still, it's just not. Then can you have satellites? Yes, you can, because from a satellite here, it can go up and it can even go like 5,000 kilometers. But then satellites have very low bandwidth, right? So now satellites can travel a long distance, but remember, it can carry only very low bandwidth, right? So then satellite is going to put across here. So that is also not possible. Can you put a like normal network cable, right? We call copper cable, right? Which is we use for networking, right? Yes, copper cables can go up to about like 1 kilometer, right? Or with repeaters, we can go a little bit more, but not, let's say I will put 10 kilometers, right? But that is all. So that is also not going to be, that's it, copper cables. So then the only option is fiber optic, right? So satellite can do up to some level, but long distance, but not a big bandwidth. So because that you can't just say like if you have satellite links or like someone is trying to sell a satellite link, yeah, that's not enough today's context, what we say, right? So we have to have a fiber optic cable for long distance. It's we call long haul connections, right? So this is what we call the internet now, right? So that like all submarine cables means these are all fiber optic cables, right? So if I just zoom out and try to understand Sri Lanka, right? We have like one important cable called CMEV, right? That is Southeast Asia. Middle East. And W is Western Europe, right? So this is a long distance cable from Singapore, passing Colombo up where through Middle East, it goes up to France, right? To my knowledge, it's about like 20,000 kilometers, 20K, right? 20,000 kilometers long distance fiber optic cable. So this is one of the bigger cable that we get, like a lot of connectivity. And there's another cable called BBG, Bay of Bengal Gateway, right? Which is another cable that is not a long distance, right? It is about like 8,000 kilometers. Likewise, you can see some cables are going over, right? Just if I clear up here. Now, we have ISPs, right? I will take one example, SLT, right? Actually, SLT is one of the investors of this CMEV cable. So they have what we call the landing rights, right? So that it will be landing to SLT data centers, right? Of course, like here, since some Dialog guys are also here, as Dialog, as a Sri Lankan company, it's not, right, owning anything, right? But now Ajantha group, so then they are one of the investors on this CMEV cable as well, right? So Dialog Ajantha, that will be all right. So let's say Dialog is just a Sri Lankan company. not that the current dialogue. Let's say go back about, I think I can't remember when it was taken over by Axiata, but before that, so then only SLT has, right? That's where like kind of a monopoly is there, because they have the fiber optic cables, right? So then if there's another ISP who does not have landing access of a fiber optic cable, they can't really give us a good rate, or there is no competition on the internet bandwidth prices, I would say, right? So in a way, it's good, like, because Dialog was Dialog Axiata group. So Axiata is here, and then they are really building on this particular cable as well. So like Dialog, like mostly it will be landed this cable into Sri Lanka, and then Dialog data center, it goes straight away. So then if you and me started an ISP, let's say we have an ISP here in Batiklo, right, for some reason, then yes, we can get customer. Let's say all MBA students are going to buy from us, right? So 2 of the MBA students and with myself, because I don't have money, so the 2 MBA students will be funded. I'll be their consultant, right? So we are running an ISP, right? But then all the MBA students, and we are giving, but only thing is to send our traffic to the internet, right? The rest of the world, we have to either bulk buy from SLT or Dialog, right? Because we don't have access, right? So then, of course, let's say Dialog is giving us, let's say, X number of rupees per megabyte, right? So we can't give X half, X by divide by 2, because we have to, that's like how the country is now selling fuel or the electricity, right? We can't do business like that, right? So then I have to increase that to X plus something, right? Y, right? Which is our profit margin, right? So of course, then it's a bit difficult to compete with the big players unless we do bulk buy and get like normal rate is Y, right? Y is greater than X, so that we got X, like X plus Z is still less than Y. So then we should be all right, at least to do business. But however, they have sort of control on us. Like say, if we are getting all their customers also, they can reduce the Y rate, so that our profit margins will go down, and probably we will not do any business, right? Even though we have a big customer tail. So there are things like that. So whenever, now I said that example because whenever you are trying to buy your internet to your company now, these are the things you should be looking at, right? So when a lot of proposals are coming to you, right? So you can ask, so do you have access to the fiber optic cables, right? So what is the bandwidth you have? What is the maximum bandwidth you can provide? So those questions you can ask, because probably the maximum bandwidth might not require your normal day-to-day work. But let's say you are a PR company or like a conference organizing company, and next year Hollywood, whatever, or like Oscar, right, is going to be having in Sri Lanka, let's assume, right? Maybe you were able to bring it, right? But then you need huge bandwidth for such a function, or maybe Olympics are going to be in Sri Lanka, right? Just you can't, we have to build grounds to have Olympics, but remember the huge bandwidth is required, right? That's why, like, so those are also key things to look into to give a contract or to a country, right? So then you can't bring Olympics to Sri Lanka if the ISP that you are having has very limited bandwidth, right? So from your point of view, yes, I would not say like in huge bandwidth you should be looking at, but still you should be knowing about whether do they have backup links if the main cable was damaged, right? So do you have a backup plan, right? If not, like, are we also going to be out of internet? Because I will show you in the next slide, like how easy to have these fiber optic cables, like we call submarine cables. So these are the questions you should be asking, right? Once you have this idea, you can do that. Now, since I told you about backup as well, like there is a cable like from Colombo. This is, I think, where was that cable? Yeah, there was okay, here, this cable. I was looking for that. A Bharat Lanka cable. That is SLT and Bharat, that India and Sri Lanka, there's a cable. So that's good, like for SLT, right? if the main cable was down, so that at least they can offload their traffic through that cable to India, and from there they can reroute it, right? This is like I don't know, transport service that you are trying to reach from one place to another, right? So when you're trying to get a quotation, so that you should be looking at, right, what options. So then you can ask from other two ISPs also what they are, like if your main cable was down, like what you have. So if you look here, Mali, right, as a country, they are either getting cable from SLT, that is called Diago SLT, that's like SLT has invested, and there's another cable coming from India called FWRF, right? So that's why, like, as Maldivians will be getting internet either from Sri Lanka or from India, right? That's because these fiber optic cables are not touching Mali. It is going just, it's like a route that they use, right? If I go back here, you can see that Mali somewhere, and that these cables are going. So you won't be able to get a tap here. Like these are the landing places, right? So that's how, like, whole internet to get connected as well, right? So just you say internet is there, you can't just get connected as long as the. I can remember, like, about again 10 years back, right? It's not really clearly shown in this picture. Bangladesh was like bit like inside here, no? They were somewhere here, I guess, yeah. So these cables were not going over there because these were like just going from Australia to Singapore and then going through Maldives, sorry, not Maldives, like Middle East, and then to Europe, right? So then they had a bit disadvantage. Like if you have been to Bangladesh, you might have seen a lot of satellite dishes are all around because they had only that option with low bandwidth. But later on, they had these fiber optic cables, right, going on. That's where, like, they are now even past us. We had from the beginning, right? So that's where, like, we as a country in a very good location. I don't know, like, that's what, like, bit unfortunate. Even from maritime or anything, we are not taking the whole advantage, right? We are doing other things. But we were, I mean, that's what I said, from 1991, we were able to get connected, right? At that time, CMEV5 was not there, CMEV3 was there, right? But we were able to get connected. So we are a bit not very progressive in that context as a country. Just one last thing on this slide, like, since we were talking about some ISPs, right? If you all are interested, you can see, like, there were some cables like called flag, IOX actually going from India to South Africa. That cable is going just on the northeast coast of, actually not, and northeast coast, right, of Sri Lanka, right? So then, yeah, let's say if you want to be an ISP, right, maybe you can have to talk to them and do investment, and then you can tap them and then have a link to here, and then you can be another ISP. So there are a possibility. There's another call called Safe Cable, which is not connected to Sri Lanka, which is going somewhere here, right, close to Sri Lanka, but there's a bit of a distance to come to Sri Lanka. But this is IOX cable is going very close to that. So that, yes, there are some opportunities, right? So you can be an ISP. So these are like big submarine cables. These are the fiber optic cables we talk about, right? So that it's just huge ones. We have to just underneath lay on the seabed, right? Just long distances, 20,000 kilometers or 10,000 kilometers. Like if something happens, the divers has to go there and do the damage repair. That's where, like, if a thing get damaged, it takes long time to repair. Let's say, like, if you want to now get the IOX cable is going, just you have to put a tap here and get it back to Colombo. So that operation has to be done here under the seabed, because you can't take the cable out and do that, right? Yeah, most like some cables, like we get, like, the next slide here. This slide which just talks about the CMEV5 cable and Bay of Bengal. Just don't look at from the slide, just type it on Google, you can find it and just read it, right? Not for exams, again, for your knowledge. Yeah, BBG cable is 8,000 kilometers. Other one is 20,000 kilometers. You can see who are the investors. Sri Lanka Telecom, right? Here we have Dialog Asiata, Etisalat, right? So then they are, when they have their ownership, that because they are the investors of that cable, right? You can get connected. So they do have access to that. If not, others have to pay and get it. This is just another picture. Like this is only about SLT, right? So because I don't get a dialogue thing, so I'm not sponsored by SLT. By the way, if the dialogue guys who are here do have a connectivity like this, maybe you can share. So I will definitely add to my slides next year. So according to SLT, like SLT has sort of like 3 landing points, and then 1 data center at Valikara, which is not a main landing point, that's a cable going on fiber. Actually, they have 3 landing points. One is in Colombo, one is in Mount Lavinia. So the CMEV 3-bell and Bharat Lanka cable comes to Mount Lavinia. So if you go to Mount Lavinia beach, you might see a board there saying that submarine cables is underneath, right? So that's why, like, when you just look at it over the sea, you won't see any ships around here, because that is, this particular area is, ships cannot stay there, because if they try to anchor, they can damage these cables, right? That's why you can't see ships there. And this other one is coming on to Colombo, I think Colombo OTS, just behind harbor, right? So that again, close to harbor, there is a prohibited area for ships to stop or anchor. Then finally, like the CMEV5 cable, which is the new cable, just landing in at Mathura, right? So this is also another good strategy, right, from SLT point of view. Again, I'm discussing this from business point of view, strategically. If something happens like within Colombo, like let's say it's not like a protest or whatever, right? Because no one can do anything to these submarine cables. But let's say some small earthquake or whatever happens and got damaged, like let's assume, right? So then all these cables were affected, right? And then we all are not without internet. So luckily, let's assume that particular earthquake didn't really transmitted up to Mathura, but with Unreal as well. But just take that example, and then so then we can get, so SLT is better off because they have another landing point a bit further away, right? So that is another good thing. And then if you are starting a business, right? If you think that Colombo is very expensive and like wherever you try to find, it's not that easy, because you want to try to be within Colombo area because you want to have a good connectivity. Let's assume, right? Today you don't need, because these fiber optic cable paths are there throughout the country, as long as you know. But however, let's say you want to get a very huge bandwidth, like I was talking about, like Oscar or whatever, some the Olympics, right? But then having your organization close to Mathura area also going to be not bad, because you are almost very close to hitting to the fiber optic cable, right? Submarine cable, right? But however, as normal usage today, you can be there as long as you have a fiber optic cable, you can be connected. So I'm not saying you have to be Colombo or Mathura, right? But that is good, because from that ISP's point of view, right? So 2 different locations. If some damage comes here, at least they have a backup within the country. But for you all, always, whenever you try to locate, you have to see whether either the main ISP has a fiber optic cable, right? So then you can get a good link, right? Because these internal cables also they have laid recently, and they were quite huge capacities are there. I think this slide I'm not going to generally explain. I think this is just to make sure that if you all can understand this slide, that means I have done my job up to now. My title is Internet is not equals to web. That is what I had explained earlier. So here what I'm saying is Internet, some definition, it is using the common TCP IP, it's an infrastructure, right? Whereas World Wide Web is an application, right, which runs, okay, it has a protocol called HTTP. We'll talk about that. Like earlier I was telling, there's a protocol called FTP in 1969 people were using, right? And then similarly in 1991, they defined this protocol HTTP. With that only the new World Wide Web came. So web and internet are 2 different things, right? One is infrastructure, one is an application. Yeah, if you have any questions, you can ask. And I will continue. I hope without giving a break, I'm trying to run, and probably towards the end to finish with maybe 10-15 minutes earlier. Is that all right, that tactic, or whether you need a break?
Can you even finish it?
Sorry?
We'll continue and
we'll continue. Okay, thanks. Okay. Right. Yeah. If I need a break, I will take a little bit. I think I'm still okay. Right? I can continue. Okay. Now I will explain. So we are now we have a basic understanding about internet, and then how it works and what is really internet. So you should feel that, right? And then web, right? Because internet, like when you try to visualize that cable infrastructure, the fiber optic cables, right? Remember, fiber optic cables is not the only thing that makes internet, because there are still some people use satellites, right? That also adding a small value to the internet, I would say, footprint. But still the huge 99% or 95% is from the fiber optic cables, because that I will be concentrating onto that. So then web is a major application. There are other applications like Zoom is not a really a web application. It's a separate application. Even Zoom runs on web. So then it becomes kind of a web. That's why like email is a separate application, right? Because it has its own protocol. I'll come to this, don't worry. SMTP, this is what the protocol is for email. So from your point of view, like I'm not expecting you to write it, the protocol name. If you can remember, that's very good. Right? At least if you can say email protocol, I'm quite all right with you all, right? But yeah, email is a separate protocol. But then someone asks, so then what about Gmail? So Gmail is running on the web. So then it's kind of a web protocol. So then it is running on HTTP, right? So sometimes people can get confused. But if you are using Outlook, so then it's basically, it's a SMTP email servers are running, right? But today, some of the applications are running on web as well. So then Zoom is a proprietary protocol, by the way. It's not a very common protocol because they use their own protocol. But then they allow sometimes to run it on web, right? Because you can, if you have not installed Zoom, even on the web browser, you can have a Zoom application running. Just as a client, you can connect, right? There's a possibility. But at that time, it is running on web. If not, it is its own protocol. So email is also like that. If you take Outlook-based emails, it's just not web, right? But Gmail, it's just a combination of web and whatever mail server, right? That's why like most people say it's a web HTTP, okay? Now, if I draw the whole internet, internet, because I use a capitalize, maybe to my data that I showed you, right? I said there are about 5.2 billion users are there. So these billion users can be real users, you and me, or can be some servers as well, right? Very small number compared to out of 5.2 billion, right? The servers, because servers also has to be, because everyone is users, right? Let's say I put here the crosses are the users, right? So then what you can do, if I have a file, if I want to send to you music file, then I can transfer you. That's all I can do, right? But no much use, like, so no business you can't do. That's where like, so you have to have then servers. I just put circles here, right? So these servers will provide us, right? So altogether 5.2 billion, right? Either server or these clients, right? So we all are on the internet, right? So that's where like now to be on the internet, right? You have to have a unique ID, identification, right? It's same as like, let's say this is like maybe I will take an example, Maharagama. Let's say all of are at Maharagama. Okay, and then this is my house. I'm not at Maharagama actually, but let's assume. So there's one of my MBA student, there's another MBA student, there's another MBA student, right? So if let's say this guy is inviting for his home, like there he's having a party, so my two friends and you can come there. So then for us to come there, right? So you have to have a unique ID, right? Because that is your address, what we call. So then number 21, right? Whatever, main road, right? whatever Maharagama, right? So that is your unique address, but no one is having, let's say another guy who is not an MBA student is having the same address. We would have gone there and then said, we came for your party. Then we had to have a good treat from him and come back. So that's the analogous, like to the normal way that we are using. So similarly, on the internet also, you have to have a unique ID. So that is also we call a word address. Since it's using TCP IP, you can remember this is that generally the IP is the one who is handling the network part. The TCP is for the transportation part. That's where like these two terms. Actually, TCP/IP is a name, as I told you earlier, right? But TCP itself a protocol. IP itself is a protocol. Whenever you have a slash here, right? So then that's a different story. This particular with the slash, a lot of people get confused. That also people ask after the lectures. So TCP IP is there, but then is this TCP transmission? Okay, don't worry again. That transmission control protocol. This is called internet protocol. So it is same. No, these are three different things. 1, 2, 3. I would say, right? But these two names appear here, but this is as one name, TCP/IP. That's a name, that a common protocol name. That's what people call suit. Right? That's the protocol suit. But this is a protocol. This is another protocol. Okay, coming back, this IP is basically relates to network. Right? I would say this is for transportation. Transport. Right? Like to deliver things and properly. Like it's like this is I would say your courier service. Right? They have a nice network. Right? They are connected. And then this transport is where app like see whether that is that the parcel is still with that person or has it delivered at what time. So that is like handling the transport. So TCP protocol is basically the TCP/IP network looking after the transport issues, and IP is network issues. So then that's what like we call this is IP address because that's the network issue, right? So the unique ID is coming from a IP address. So that is very much the case. So everyone has to have an IP address. So if I just put a dot here, these blue dots are everyone, servers, clients, everyone should have a blue dot, right? And then we know that we need 5.2 IPs, a billion, I would say, 5.2 billion IPs in order to accommodate as of 2022, let's say. This is the current statistics, just assume, right? These are all statistics, by the way, right? So then if we have 5.2 billion unique IP addresses, so then there's no issue. That is what probably we will be working on. Now, the computer, these all are computers, by the way. And you know, computer can understand, right? Understand only two things, 0 or 1, right? Good or bad, that is what, right? So not exist, exist. True, sorry, true, false, whatever, right? Have current, not have current, right? So whatever, that's what like we can explain. So this is what we call binary. Right, so binary is the main language. The computers, electronics inside that can understand ones and zeros only, right? That's why in one of my images that we just passed that I have ones and zeros only in the back end. I didn't talk at that time, right? That is what the reason. So that computer can understand only ones and zeros. So now, with respect to these IP addresses, just try to keep the same. IP addresses here. Can you remember if I go back, I said, I'm not going to the slide, but if I recall back, 1982 only, the TCP/IP was proposed, right? That's the year that was proposed, this protocol, 1982. So when they are proposing TCP/IP, right? So they have to define this IP addresses structure. right? So what they did was they allocated some space to write the number. Remember, these numbers are all going to be binary. So then 1 0 1 1 0 1 0, it goes on like that, right? So that is how, like, you can write numbers. Another number can be 1 1 0 1 0 1 1, right? So like that. So then now we can say now your grade 10 mathematics will come here now, right? So if I have like 1 2 3 4 5 6 7 8 locations, right? How many combinations I can have this? That is like, since it's binary, 2 to the power 8, right? Which is about 256, right? And so only 256 numbers can be generated. So that is our normal mathematics. Now, in 1982, when they were designing TCP/IP, they gave IP address 32 bits only. Only 32 bits were given, right? So now if we do a little bit of mathematics, again, grade 10 maths, 2 to the power 32, who can tell me, right? Which comes like something like 4.09 billion, right? So now you can see here what the current state we are in, right? So this is, always try to remember this, like this was done. So those people who were, right, allocated in 1982, only 32 bits. So then according to them, only maximum you can have 4 billion, right, unique numbers. So now you can see there is a big issue, right? As of 2022, we have about 5.2 billion users, right? How can we accommodate that? It is impossible, right? So this is what we call sometimes digital divide as well, because the internet itself makes us a scarcity of some resource, right? That is IP addresses, because according to the definition in 1982, only 4 billion IP addresses can be, but we have about 8 billion population, right, in the whole world. But out of that, as of 2022, we have 5.2 have been already connected, so we can accommodate them, right? So theoretically, I can't say there are 5.2 billion users, because we can have only 4 billion, right? That is like overfilled. But that's where, like, so this was rectified in 1993. So not rectified, identified in 1993. And about 1995, right, they were able to rectify this problem. And then there was another version of IP addresses has to be designed. So that's where, like, today we have IP address 2 versions, version 4 and version 6. Now, a little bit technical, don't try to get so excited or upset about this, right? This, when in 1982, when we designed, that is what we call version 4. So don't ask me like what happened to version 1, 2, 3, right? So no one knows, like, don't worry about that, right? If you try to find that, you will not be able to do this course as well, and probably pass my course as well, because you will be finding that. And also, like, don't ask me somewhere in the middle. So then 1982, like you say, version 4, then what happened to version 5? Just ignore that, right? So that was also like, that was there, like it was called experimental, right? But just for you, I will say it's not there, right? So it was there, but for some experimental purpose only, but release version is 6. So we have only 2 versions, right? That's what you all have to remember. The first design version was version 4, which 1982. So later on it modified to version 6, right? So version 6, okay, where was my space? And just trying to keep this without cleaning, so that this is about having 128 bits, right? So anyone who can find this number, right? So you say it's a huge number, I would say here, right? So now there's no problem, right? So here, now we can accommodate more than, right, 100 billion, right? Even more than that with V6, right? But with IPv4, as internet was not evolved, right, and we just kept 1982 model as of today. So 1.2 billion users are waiting to be connected as of now, right? And then one of us has to exit from here, so that to accommodate one of them, right? So then only new one can come, right? So that's where, like, whenever now we disconnect, right? So that IP allocation will be reused to someone else, right? But still, there will be 1.2 billion now waiting. So that's a huge number, right? So after introducing of IPv6, that was kind of sorted out, right? So then there are two versions of IPv4 and IPv6, right? So if you, I hope you got the point, right? And I hope I have not confused you all, right? So however, remember, even with the current internet, if you do not have this unique ID, you can't get connected. So remember, no duplicates can be here. So like my IP is this, none of y'all or anyone in this world can have this IP, right? To be connected to internet, right? Then there's going to be issue because two people exist with the same ID. So then transportation of goods, or in this case data, right, cannot be done properly. So that all the protocols and all the routers, all the devices which is operating this will get confused, right? That is what the reason. So there are two versions, right? So that you all have to remember and then know about that, right? And also, like, can I get another white screen here? I will take another scenario now. I said you all here are for decision-making process, right? So again, I am Ajantha here, the sales guy. So you all, I have a network printer, right? And then I'll be saying that this is, again, I'll take 1 million, right? And then I said there's another printer, like normally you are trying to get your IT department has done the specification, right? So then when you get the quotations, it's got 1 million. Whereas I am saying I have another network printer, like this is Ajantha model, right? Which is, again, let's say, I would say 500,000, right? 500,000. But now this time, like, I'm not going to try to put that conditions like whatever I had earlier. This is using TCP/IP. Good. So you said, okay, you are past that TCP/IP. This is what, like, we normally call. So TCP/IP, no proprietary. So print per page, like all the other parameters we were comparing. So just no issue, right? 1-to-1, right? So then now just say this is half a million. This is 1 million. So now you can make a decision to go for which one. But then another one question you can ask is where are you using TCP/IP, which version? So he said, okay, this particular model uses version 4 and version 6. This model just uses only version 4. So now you might say, okay, that's all right. This is only version 4. That means it is working, right? But remember, I will show you some statistics later. We have to move away, right? So still we don't know the time period. That's where, like, so let's say if we have, if I just draw as time goes on, let's say this is where we are now. This is currently at 2022. This is the V4 one, right? I'll take another color. Let's take V6 started in 1993, somewhere here. So it's slowly starting and then it has to go up, right? So the expectation is this has to go over, right? This is the expectation. I'll take a different color for that. This is where the expectation here has to go down, right? Because like after we don't know, I will say 20, right? XX, right? Somewhere 2030, 2025, 2027, right? Still no one knows. Like after that, we expect this to go down, right? And then we used only V6, right? So let's say this is, let's say 2025, right? That means after 3 years, your printer cannot be used. So maximum, if you are using only for 3 years, that will be all right. Still, we don't know whether it's going to be next year or 2025, right? But that's another challenge or doubt that or gamble that you do, right? So that's where, like, whenever my recommendation here is, whenever you buy equipment, network equipment, always look for V6 and V4 both, right? Because don't go only for V4 if you are buying now, right? So new purchases has to be supported V6, because in the future we might have to, we all might be moving to V6, because V4 we have to throw it out because it's too old, one thing, and it is too small, right? So rather than say too old, too small is the main issue, right? So let's say now someone can say like, can't I stay without moving to V6, right? Can I be in V4? But remember, just network is like related to internet. Let's say your ISP, right, has moved to V6. So then your V4 devices, right, cannot work. So one other thing I couldn't tell you, V4 and V6 are incompatible. Incompatible. I have a note later, so don't worry. So that is incompatible. That means a V4 device will not work in V6 environment. V6 device will not work in a V4 environment unless it is V4 supported. So because of that, so these are two different worlds, right? So people who can understand mathematics, you can see this. V4 is a 32-bit IP address. This is a 128-bit number. So no, you can really understand how can you put a 32-bit number to 128. You can sort of do it, but putting more zeros there. But let's say one way is all right, but other way around you can't put it, because 128-bit number you cannot represent with 32 bits. So that's the simplest thing that is saying that incompatible. So these are two different sizes of numbers, right? So you can't represent that. So that is why they are incompatible. So that means if we are, the whole network is V6, all devices has to be V6, right? If the network is all V4, it has to be V4. But remember, we are now in the mode of moving from V4 to V6, right? So then your new purchases has to be any network, right? Need not to be a print only. Just you buy a wireless access point or just a router, right? Computers are okay because computers are software based, and then the software, like if you are using Windows 8 and above, that no problem, they are supporting. So computers are kind of all right, but you don't have to worry. But especially network devices, right? Any network gadget, right? You have to check whether it's V6 supporting, right? That's how like your new purchases has to be there. So coming back here, so that is the important point, right? And then the uniqueness. So now I clear up this and then come back to my note. So I said it has to be unique, right? And numbers has to be assigned. And then yes, what is V6 that I just explained? It's a bigger size of V4, right? Because it has 128 bits, right? Compare other one. Why it is required also I told you, right? So this is their 32 bits, right? And then V6 has 128 bits. Like I said, 2 to the power 128. This is that number, right? 10 to the power 30. It's a big number, right? So you don't worry about, like now if someone says still is it a capacity if we grow like in a 1,000 scale or 10,000 scale, just you can grow like 1 trillion times, but still this is a huge capacity, right? So V6 will not get full. So then I said that the compatibility issues is not compatible, right? So that is the important point you all remember, because that is why you have to be always concentrating. So that's where like, especially with respect to computer networks. So this is, I would say now someone said it's a bit of a headache, like why this has happened, right? Unfortunately in 1982, right? When the designers were designing the TCP IP model, right? They never thought internet is going to be this popular as of today, right? Everyone is going to rely on that, right? And that is like a huge thing. So they would have done like 128 bits that time period. So we won't have any issue, right, with this, right? But unfortunately, they thought maybe 32 bits, 4 billion is more than enough. It is not going to be that popular. So that's, you can see the perception in 1982 into now, right? Just about like 40 years, right? So like how things have changed, right? That's why like predictions, maybe the highest level, right? Top level also could not be able to predict that. So why V6? You can see huge number of connections you can have. So that whole connectivity, there's no issues going to be, right? Given that the devices has to support V6, right? By the way, these slides are not for exams, right? But just to tell you a little bit onto that. The 32-bit, 120-bit you should have, because when you're comparing, because I have asked in the exams also, like, why do you want V6 when you have already V4? So you have to explain that. But these examples, these are like address, how it looks like, how we write an address, right? And the number of addresses, like this is 2 to the power 128, if you write it as numbers, right? If you, I think you have to ask from Ms. Rosie Senanaik how to pronounce this, right? Then she will tell how to tell that. So this is 4.2, not I said 4.09 billion, but it's 4.2 billion, right? Numbers are there, 2 to the power 32. So this is like, I can't tell also, like 340, I don't know, it's like billion, whether there's a name for that number, I also don't know, right? But it's a huge. So I will not ask like the sizes or whatever it looks like, but even I don't really ask the years, like when did it happen, but I just said in my note as well when I explained, but this is important thing, like at least if you don't remember, right, then two numbers, right, where I said this is a bigger number, right, compared to this. So at least then you give that message. Okay, this is some statistics I have to show you that if you all want, just type this in Google, IPv6 adoption, right? Just type that IPv6 adoption, then you will get a link. Actually, Google is monitoring how many requests are coming to their server with V4 and how many requests are coming with V6, right? So now we can see this is a V6 graph, right, as time. So this is like up to 2019 is here, but now if you just go now, you can get as of 2022 May, right? Maybe yes, till yesterday, probably they might have. So this is the percentage we are talking about. This is about like 30%, close to 30%. Or like probably now it has moved away 30%, also maybe has come up to 35%. That means Google traffic, out of that 35% are V6 and maybe rest of the 65% is only V4, right? So let's say next year when we try, right, maybe you might be looking at that, right? So let's assume now, I'm predicting now. Let's say this is 45%, this is 55%, right? Another year, so this is 2023, this is 2024, I would say this is 60%, this is 40%, right? So that you might see this is improving and this is decreasing as well. Now let's take the same concept I'll come to the next other one later. I'll take another white screen and explain from business point of view, right? So that's like it's important thing. So now V4, we know there's V6, right? We know about this, like the growth. Currently, we know it's about 30%, right? This is not like whole world, by the way, right? Someone can misguided by my explanation. I'm saying Google is monitoring, right? But Google is a kind of a good indicator today because everyone use Google, right? That is Google service, especially like Google search engine, right? Actually, this is, I think, Google search engine's traffic, like they are looking at. So that is just an indication, like 30% roughly, right? Now, this is you have a big e-commerce site, right? And you will be doing business and like maybe Flora or Lasana or whatever, like eBay, right? Let's say you are the owner or you are the CTO, CEO of that company, right? And you know, like you get customers and you are doing business and you seems okay, but over and over, year by year, when you try to project and look at it, your customer base, you can say it is reducing, right? Let's say your customer base was like, let's say 60%, right? So now it has reduced to 50%. Now it's about like 43%, right? So this is 2022, 2023, 2024, like just assume like this is where you're monitoring, right? So you will say like customers are losing. Is our products are not good? We are doing the same service, or we have an improved service, right? Is our internet bandwidth is the issue? No, like we have increased over a year, like a bandwidth, and the IT guys are saying that bandwidth is not congested. Is our servers is a problem, because the servers are not going to be that big issue with the e-commerce. But let's say like, no, they are not giving heavy loaded, like it's about like 50% utilization. So that the IT department says that you don't have to worry about too much on that. But now what's going on, like, are they like really don't like our product, or do we have like another competitor, right, who is doing similar products, and are we losing our customer base? But let's say everything, when you look at everything, is just no, you are okay, right? You are positive your side. But what I'm saying here is, did you watch whether what sort of traffic you are getting, like all V4 traffic, right? Because your server, let's assume your server is V4, you have never upgrade that to V6, right? Let's say V4 is here. But you see that now the customer base is moving to V6. But now, since it's incompatible, so remember this V6 customer can't come to your e-commerce site, because if your site is running on V4, you can't get a V6 customer. They can't do a transaction, right? So you can see how, why, and you can have so many questions from me, right? But this is not possible, that it will not work, right? So when they try to come to your e-commerce, www, right, labai.lk, whatever, right? And then they can't come there, but that website is not accessible because this guy is using V6 address and your server is running on V4, right? Simple as that, right? So that means that if this customer base is like moving to V6, and if you have not upgraded your server to V6, or like in this case, actually not upgraded, because you still have V4 customers as well. So what we say here is you have to run dual servers. You have to have V4 and V6 both, because that is what from business point of view. As individuals, you are not worried, just you move to V4 to V6, that you can do, right? But only thing is, from business point of view, you can't do that, because you have to capture your old still, because there can be, because if one day the whole world says that we have stopped V4, then you can shut down your V4 server, because you know that no ISP in the world, right, will be supporting V4. So then you can easily close down V4 server. If not, right, it will not the case, because there can be some customers, still your old customers are coming that way, right? Because there is no, we call flag day for V4 to V6, because no one can tell that, because it's a huge investments each and everyone has to do in the organizations wise, right, to upgrade their networks. Now, if you are moving to V4 to V6, you have to upgrade all your switches, all your routers, right? Your network equipment. It's just not like, say, have a V6 server, right? The network guy says, sir, we can't do that, right? We have to upgrade all other equipment as well. That's where, like, another good thing, like we'll take that context later when you go to cloud, because that's where like the cloud contexts are not here, because that's, we have to talk that separately, right? So don't get yourself confused, right? So now if you are running your servers like on your premise, like on premise, right? So this is what you all have to face, right? So if it is a cloud, it's a different story. Like, so don't compare now apples with oranges. We'll talk about apples and then try to understand, and then we'll move to another thing. So you have to upgrade your whole network. Now we are talking about, you are the CEO of Mars Holding, right? Or you are the CEO of Sally's. It's not just simple, right? One, like 2 switches or 2 routers, like this whole organization. That investment can be $1 billion or $1 billion, right? So will you be able to touch that? That's like a big ask. That's what I said. There won't be a flag day. Flag day means like someone says that after this date, no V4, right? Because it can't be, right? But however, as CEO, so you have to think of this, right? And then you have to make necessary actions year by year, propagation, right? Then only you can capture. If not, you are losing your huge market. And you are doing only e-commerce. That means you have to somehow capture that market. If not, you are losing, and then your business, you are losing as well, right? So whatever your management theory is, right, everything is good, right? But then from this IT perspective, right? So that is also very important thing to look into. If not, you will be losing, keeping all your other things intact, right? All your results is positive, but you are losing, right? So that is very important. So this V4, V6 is a huge impact in the future, not now, because we are slowly like in Sri Lankan context only, right? So I don't think even maybe 5% or less like we are using throughout, like our ISPs are using V6, I know that, right? So it's like the V6 traffic in Sri Lanka is not very bad, but however, as organization, I won't say even 1% to 5% we are doing that now, but we will be moving, right? That's where like you have to think of these things now onwards. You have to plan for that from now onwards. So then it will be not a huge impact for you to move everything straightforward, right? So whenever you purchase new equipment, always you have to say that everything has to be V6. So then you slowly upgrade. So within 3 years, you might be all right with that. But if you just without knowing, without considering these things, if you try to upgrade your machines, server equipment, network equipment, so then basically you will be facing that problem. Clear here. Yeah, the next slide is also like not for exams or whatever, just say that if someone asks, so is V6 is better than V4, whatever, right? Yeah, this is just some, I just took some research results of someone. I just put it here. I didn't do this. This is an outcome of someone who has done an experiment. So this is red is V6, V4 is blue, right? But the performance wise, it's just not like if someone asks, okay, I think I can't remember whether I have asked that question in the exam paper. If not, probably I will try to check whether I can ask from you all. Yeah, we are using V6 because it is very fast, right? That's just a wrong statement. Like it's not really comparison wise here. Like it says like this is comparison between these two. Like it says little bit, right? It's not a very fast. Right? So I would say here very, right? So then it's not very fast because of not the reason we are moving to V6. We are moving to V6 because the capacity, the space allocation, because 2 to the power 32 is a big issue, right? This 4 billion, right, is not enough. That is the main reason, right? It's not like someone didn't like this V4. That's what we are going to V6. Oh, it's very fast. It's very sophisticated, solid, state of the art. No, nothing, right? It's just basically the capacity. That's what I just put this picture here, right? I will not ask like anything else on that. Now, okay. Probably at least I will try to ask a small question from you, right? Maybe I will try to get some answers from you. Now we talked about internet. And so we know something about web as well, right? Because web is an application, right? And we talked about IP addressing, V4, V6, everything now we have discussed, right? And we know how internet started as well. Who owned the internet? So this is my question. Who owns the internet? Can you tell someone tell me? Who can be the owner of the internet?
ISP provider.
ISP provider, because okay, I will take some examples and then I will this is how I like to teach, right? So you will have to ISP provider. Any other answers? Who owns the internet? Is there? You can tell a name or ISP provider, right? Don't look at the note, by the way. What do you feel?
I feel like it's not owned by anybody. Like it's collection of
Nobody.
servers. So
Yeah,
you know,
yes,
data.
collection. Nobody, right? Good. Yeah. So these are good discussion points, right? Any other who want to add the third one? Yeah, these are all your doubts. That's what, like, this course is more, I'm just trying to get your doubts cleared as well. That's why, like, maybe you can put your doubts to me, right? I will try my best to see whether I can give you a solution and explain to you all as well as the whole group. Any other answers? Who owns the internet?
Everyone.
Everyone, nobody, everyone. Good. Everyone. Okay, I think that's a good thing. First of all, internet is an infrastructure, right? I'll draw it now like this, right? Just make it. So it's an infrastructure, because we don't want to talk about web now here, right? Because I asked who owns the internet, not who owns the web, right? So then this infrastructure has to be owned, and then these are cables, fiber optic cables, F4 fiber optic cables, right? And some other networking devices as well involved with this connectivity. Not just fiber optic cables cannot provide us that. That's what, like, I don't want to teach you like routers, switches, what is the difference between them. Just, it's not your part, right? But some devices called routers or switches are being used, right? You can say networking devices, right? That's what, that is enough for you. And then fiber optic cables will provide us the connectivity, and the infrastructure can be built. But what is the most important to essential thing on the internet? What is the most important thing? Like, okay, you have to have first cables and these devices to get connected, right? After that, what would be the next most important thing?
Address, IP address.
Very good, very good. So that's full mark, right? If I ask that, if you tell that, full marks will be given. So IP addresses, because without that IP addresses, right, you can't have the internet running, because I said it has to be unique numbers. Now, we know, let's talk about only V4 now, right? So don't get confused yourself, V4, V6. It's just like we'll go to 1982 and discuss this, right? So V4 only. If we all have, now let's say the users are here, right? All over millions of users are here. If IP addresses are just floating, like someone said nobody, right? Someone said everyone, if we are the owners. So Ajantha will be using IP address. I said just one, right? It is not a one, like it's a 32-bit number, right? The person, let's say someone is in this class, someone is using IP address one, because someone says it's my one, like this, I like one. Ajantha also likes one. So now there's a confusion, like this is not unique, right? So now we have everybody, everyone or nobody is wrong answers, because if we do not have a control for this, because this is a scarce resource, by the way, right? So then there's going to be an issue, right? So then I would say nobody and everybody, it just, we feels like that, but you can't really manage, right? Because just think of like a business now, right? Because the internet has to be managed, and then IP address is the most important, essential. And if no one is controlling that, there's going to be an issue. So we have to have a controller, right? So will it be the ISPs or will it be someone else? Actually, there has to be owner. Yes, there is a owner, right? Answer is yes. Oh, actually, here is who is the owner is not the answer. Like, will there be owner of the internet? Yes, right? That means this, the controller. The controller is called Internet Corporation for assigned names. By the way, names we had discussed, we call domain names. That's what this name stands for, domain names. And numbers. Numbers is IP addresses, right? So that we call ICANN, right? So ICANN is an organization, right? Actually, it's a not-for-profit company, right? Earlier, USA Department of Commerce is like 2 reps were there. 2 representations were there in the board of management, right? So there's a board of management here, the BOM, right? So then 2 of them are from USA Department of Commerce. They appoint, right? Others have been appointed in different ways, like we don't want to talk about. I think this is the general group, right? So the international business group, or if you all are more into that, you can read more about this organization, how it works. So they are the controlling body, right? So they owns the IP addresses, not the ISPs, by the way, right? So they own the IP addresses. They owns the names. Like if you say something.com, CNN.com, they own it. They later on, they have to sell that, right? So they own this IP address. I just put a number like that. This is a number, right? That is actually a V4 address like a number, right? But this IP address was given to Ajantha. Let's assume, right? Ajantha cannot be purchased like that IP addresses, but it has to, then only that the first answer ISP will come. I will talk about that, but how I just assume. So that is been sold to us. So this is been sold to someone. This is also being sold to this someone. So that means we have to purchase, right? IP addresses and domain name. They are not coming for free because this controlling body charges for that. That's how they basically control as well, right? This was the organization, right, till about 2016, right? Before 2016, if I say, that is what I was explaining, right? But you know, there's a lot of resistance because, by the way, internet is coming as a byproduct of defense work of University, not University of Colombo, USA, right? And then, of course, the web is a different thing. Web came from CERN, like it's a European guy who came up with that protocol, right? But internet is basically designed and developed in USA. Later they make it available to everyone to access, right? That's why like USA had a chair or two chairs here in the controlling body. But then, however, Russia, China, I think Iran, right? So those countries were really fighting for this, like, because one country having this, right? That means like they can be the big brother, right? So if they want to block a country, block a domain like .com or .lk, right? They can do, because this board can decide. So it's where like there was a lot of resistance and saying that no country should own. This is now internet is everybody's. That's why like someone said, it's everyone, right? But however, everybody, there has to be control body, but then no country should have footing on that. So then later on, ultimately USA decided to move away from this, right? So if I come back, I just clear this. So the contract regarding the IANA means another organization before ICANN, that is called the first organization, Internet Assigned Numbers Authority. That's what I call IANA. IANA is the one who later on created this ICANN company, right? So then the contract regarding the IANA functions between ICANN and the National Telecommunications and Information Administration of the United States, right? Department of Commerce ended in October 1st, 2016, and then transformed that to a global multi-stakeholder community company like organization, right? Still the headquarters is in Los Angeles, right? So there's a CEO and the president and everyone. Now, no country owns this organization. Because of that, you can't say USA has a footing, right, to make decisions about internet. But now it's a real multi-stakeholder, global multi-stakeholder community, right? But there is an owner. Who is owner? ICANN, right? So if you say IANA, that's a long time back, right? But then it was ICANN, but now today we call ICANN, but ICANN has no footing for a country as of now. So what ICANN did was they convert or transform the whole world into 5 regions. And then these 5 regions are, these are the one. One is called APNIC, Asia Pacific. This is our region, but I have put it a different color. The other one is called North American region. And then Latin American and Caribbean islands. The RIPE is for European. Afrinic is for African region. So these are the 5 regions. It's just not the 5 continents or whatever. They just did it, right? So ICANN converted this into 5 regions. So ICANN, and then these 5 regions were here. And then say I take APNIC here. So they had a, let's say, let's talk about V4 addresses. The 4 billion addresses, they have divided to these 5, right? Let's say they got 2.5 billion, because that's where like APNIC, this Asia Pacific is where like the lot of the huge population is, because China, India, Korea, Japan, and up to, I think, Afghanistan is like where like the population, like that's the biggest population, ethnic, right? So they have given, so whatever they have used the policy, right? Actually, they have given free of charge these IP addresses. So the controlling body gave the IP addresses to these 5 RIRs. RIR stand for Regional Internet Registries, right? So 5 regional internet registries were given the full control, those whatever, so that V6 also they have allocated, right, for these 5 regions, right? Actually, V6 only 20% they have allocated, 80% they have kept it, because 20% is more than enough for another 100 years, probably, I don't know, but it's a huge amount they have allocated, but that huge allocation is also what they say is about 20%. So they kept 80%, ICANN is still keeping that, but if they need, we can give. So now APNIC has V4 addresses and V6 addresses. Okay. So similarly, other 4 regions also have that. So I'll take, do I have another slide here? Okay, I don't have a slide there. So I'll take white screen. Okay. Now we have ICANN. And then it's good. I will talk about our region only, APNIC, right? There are other regions like that. So we got, now let's take SLT, and I'll take dialogue as well. If not, my dialogue friends will say I am always talking about SLT. So these are ISPs, by the way. So actually they have to go and buy, by the way. So they have to buy. Now here, I think this is free, right? Because they have just, the controlling body don't want to make money, right? They have given to, so you have to buy. So similarly, dialogue has to buy, right? So they will give IP addresses, whatever they ask, right? And then it's just priced, right? So each IP address has a value. So now these are the customers, you and me. That's why I said I can go and buy it from APNIC earlier. The customers has to buy packages from, so again, you have to buy. That is what you have to pay for your internet, right? So if someone says internet has to be given free of charge, right? That's you without knowing the things like, by the way, SLT has to put a infrastructure development to get a link. Let's say you are getting fiber optics, so they have to place the fiber optics, right? You are not paying for that, right? So SLT has to recover that cost as well. And so also they have to recover the cost that they have to pay for the IP addresses, because whenever you connect, they have to give you an IP address, right? Maybe that's, we call it a dynamic IP address, because later on, there's another customer here. So let's get another color. So this is, so that they will be giving that IP to this customer later on, right? Whenever you are not using, but still they have to charge, right? Because they have purchased those IP addresses. So it's how, like, same thing, dialogue, right? So people can't go and buy, right? You have to go through always ISPs. ISPs has to buy through the regional registers. These are the RIRs, right? So regional registries will be getting IPs from the top owner, that is ICANN. So this is how this is being managed. Okay. So if you want, let's say now mass holding, right? They need about, let's say, 10,000 IP addresses for their whole operations. Yes, that kind of a bulk, if want, they can go and buy it from APNIC, right? So you can do that, right? So I will tell an example. We do have an organization called, where's my, called Learn, L-E-A-R-N. Learn is a Lanka Education and Research Network, which is all the 16 state universities are connected, right? That's a company kind of, it's owned by the UGC. So UGC owns this not-for-profit company, right? And what they do is they just act as an ISP. Actually, they have purchased IPs. So whenever, if you look at it, our IP addresses are Colombo, Moratuwa, Japura, Ruhuna have similar starting point, because they all are similar, because we are not buying it from our ISPs. we have bulk buy a lot, right? I can't remember the number. Like, let's say if you maybe more than 10,000 probably, right? So we have purchased that. So, but however, whenever let's say University of Colombo is here. So whenever we get connectivity, we get, let's say, I'll take dialogue, right? So we get through dialogue, but dialogue will, we say that, okay, we have IP addresses. So dialogue will be using the learn IP addresses to get connectivity, and not this one, right? To go to internet like that, the internet connection, right? So dialogue will be using learn IP. So that's why, like, then later on, let's say University of Colombo says our service provider is not dialogue, we want to go to SLT, we can still use the same IPs because learn is paying every year for that, right? So by the way, we pay to learn to keep that connectivity and IP addresses, but not the connected IP addresses. Connectivity, because learn is not a service provider in that context, like giving links like fiber optic links to each university. So then we take it from the service provider. So that's, so yeah, if you are a big organization, yes, you can buy your own. Then those IPs will be with you, but you have to pay for the ethnic, right? If not, like, you can buy it from SLT. But when you buy from Dialog, you will get one block of IPs, right? So when you finish the contract and say next year I'm going to go with SLT, then you will get a different block because that is coming from the SLT pool, right? Now, one other important thing I want to tell you is, I told you there are V4 and V6 IP addresses. Regarding V4 story, all V4 IP addresses which ICANN had, that is 4.2 billion, right, IPs, have allocated everything. They have zero, right? I say availability is zero. That is ICANN, right? ICANN does not have anything. They have given all the 5 regional registries all the V4 addresses. They have finished that. I think probably 1990 or something. They said, like, they have finished, given that they don't have any. Now, APNIC got a lot from that 4 billion. And then in 1992 or 1996, whatever, APNIC said they don't have any. So they have V6 numbers, sorry, are 0, right? So APNIC says they don't have any V4 numbers, they have V6. Now, SLT has purchased and Dialog has purchased bulk buy from APNIC, and they might be having, right? So this part I also don't know from here onwards, right? Maybe some of you all can update me if you know internals, but this is like business related as well. Now, let's say SLT has, this is the example now. Let's say 100,000 SLT has IP addresses. Now, let's say 95,000 they have already given to different customers, but they have another 5,000 available, right? Just assume a case here. Now you all are starting a new company, right? After recession and everything, Sri Lanka, like your company has upgraded, and now let's say you are doing IT related stuff as well. You are getting 10,000 people, right? And try to do some business, and you go and say, can we have a IP address, 10,000 IP addresses? So SLT can't give you 10,000. They can have some other solutions, right? I'm not saying they can say like we can't, but that issue is there. So that means they will say definitely we can give you IP address, but not V4, V6 we can give because we don't have V4, right? So I also don't know how many remaining Dialog, how many remaining SLT, but APNIC has said they don't have any. That means SLT or Dialog or any other in the Asia Pacific region can go and buy any V4 addresses from APNIC. So that means, just I want to tell you the story I was telling earlier. There will be a day your company will be trying to use V6 numbers, right? Because you will not be able to expand with V4, right? So that means this is where, like we say, we can see slowly people will be going into V6, right? So that coming back to my your CEO kind of scenario, where your customer base, you will be having more V6 users in the future, right? So if you start not thinking of that and try to take action from now onwards, definitely you will be losing another customer tail, like that particular sector will not be able to access, right? So that's what, like, V6 is inevitable, so it will be coming, right? Because V4 scarcity is there, and already our region has finished. So that means our ISPs will soon finish, and then probably we all have to move to V6. So if we do not have a plan to accommodate V6 and V4 together and do our businesses, right? If we are individual, it's a different story, but if it's business, you have to cater, think for both worlds as well, right? So that's how it works. So this is how the whole allocation of IP addresses and who controls, who owns, right? Who has the upper hand, right? Or who is a big brother? There's no real big brother now, right? As a country per se now, right? But ICANN is a big brother, right? With respect to internet connectivity. But APNIC is a regional registry which manages everything, right? So then from there onwards, everything is money. Yeah, any questions you have or any doubts still? Or is it clear? What to do? Okay, before go to the next slide, I will take another scenario and discuss with you all to get this discussion more information, like then you can start thinking. Now, I will present in a different way the same story, right? Now, this is you. Let's say you have a ADSL connection on fiber, right? So now fiber to home is there, right? That is, we call FTTH, fiber to the home, right? That's what, like, probably this SLT can do, because Dialog is more, they don't have like more cable, but fiber they will come, right? Because they have issue with copper cable, because only SLT has laid cables long time back. That advantage is there for SLT compared to Dialog. So that's why the Dialog is more concentrating on wireless solutions like 4G and coming up Wi-Fi and things like that. But let's take this example, right? Yeah, it can be 4G or whatever example is also all right. So this is our ISP, SLT, and SLT is connected to the internet. I'll put here capital internet using V5 cable, whatever, right? That is a submarine cable. So that's how you get internet. Now, on the internet, so I'll just draw the internet like this, and then there are some 2-3 services. So I'll put this has to be inside the internet, but I'm just taking out just to highlight that. So Facebook is there, and then this is your LMS, that is management faculty LMS. It should be within the internet, right? And let's take just another one, right? Some news, right? Or YouTube, right? Whatever, right? Because my scenario is, that's how I'm trying to explain you the scenario, right? Now, this is you. Let's say what you do normally with your connection. You go to LMS and get notes and whatever video recordings, right? That's what you do, right? And then you used to go to Facebook and updates time to time, and then you watch YouTube video. That's all. Let's assume you are doing that's all, right? Let's say you have to pay through ADSL per month, let's say 5,000 rupees, right? Per month. You are doing that, right? So like, so these numbers and others is irrelevant, right? Just assume you are doing only these 3 things, right? And you are paying 5,000 per month. Right? That is your monthly bill. Right. So you do this. Let's so you don't do anything else, right? Because like, then your discussion will go all over the way, right? So you are doing these 3 things, and then you are paying 5,000 per month. Now, my question here is, who are the people getting this money? So you are paying 5,000. You have to tell me, now you have to give me a balance sheet and tell, these are the people who are getting 5,000. Yeah, maybe you all can start giving me answers. Then with that, I will start explaining, right? Rather than, because that's what I would like to get your discussion, and on that I can explain. You can give right, wrong answers, right? Don't try to give me, you can give some stupid answer. If you really know stupid, don't give that, because then everyone thinks that it's a stupid. But yeah, if you think it's a bit doubtful, but maybe, yeah, I will explain that. Who will get this money?
Land provider, local area network.
That's it. This SLT, right?
SLD. Yeah.
Okay, let's write down one SLT. So anyone else?
Then there's a wide area network provider, WAN provider, that CME.
CMEV cable provider, right? Okay,
Yes.
let's say
WAN.
cable owner. I put CEO, right? Cable owner, right? Yes, good. Cable owner. Good. Cable owner should get, because that is another important thing. Who else? 3. Anyone else?
Apnic.
Apnic, no. No.
It's
no.
a one-time payment.
It's SLT has to pay to Apnic, yes, right? Not my.
It's one-time payment, I think.
Yeah, it's a one. That's like every year they have to pay, because there's a renewal of the IP address pool. They have to pay. Yeah. So, but maybe from my money it will be going, but directly I'm not paying. So Apnic is a kind of a third party. So if you give it as an answer, it's the wrong answer. But yeah, Apnic should be getting some money from my money. That is through SLT. Okay. Others? Is that? There are some. Okay, I will tell. So there is a 3. Who else? Anyone?
Government for taxes.
Very good, very good. GOSL, right? GOSL, Government of Sri Lanka through taxes. Yes. I think that's all. That's all to my knowledge as well. So these are the 3 people who are getting money. So that is like whenever you do internet, right? You go and watch lots of video at YouTube. When you do Facebook updates, live updates, right? I am having a stupid lecture now, right? Very boring, right? Still, you're updating every 5 minutes, right? Still, you are using, and then you are just accessing your LMS because you have to finish somehow the MBA. If not, your parents or your partners will be saying, okay, why your whole money you spent going to be wasted. So then that's what like you are focusing, but you are paying 5,000 per month to have this whole connectivity, but these 3 guys are getting money. So now, if we just talk about internet and web, who is making money? The internet guys, right? SLT is an ISP. Cable operator is internet infrastructure. GOSL actually is no one, right? So there's our government. So this has to be reduced as much as possible and try to make it 0. To get the penetration level I was talking about, because if this number is much more bigger than 1 and 2, that is what like another thing, right? So we need people like ministers to think on that, right? And that's where like how the penetration can be. But however, so yeah, the first and second actually relates to this. 1 and 2 is related to here. So that means web is what? It's kind of free. You don't pay for a Facebook. You don't pay for YouTube, you don't pay for LMS. Okay, of course, you have paid your tuition fees to University of Colombo, Faculty of Management. But these are all web stuff, right? So web is actually free for you, right? But you are paying for internet, right? That's why like earlier I was telling, right? Either you have to be like, if you are really investing your money, you have to be an ISP or you have to be a part of cable owner or cable operator, right? So then you can make money. Everyone is using internet. That means they are getting money, right? If you are trying to keep a nice website, right, to update how to do this and that, right? But you can't make money. But of course, that's where like there is indirect way. That's like you will study as well, right? So through advertising and other forms of things like in e-commerce, you will be studying those. But that is all right. But I'm saying about this from 5,000, you won't get any. Right? So you have to have a different business models to make money, right? Facebook is making money a lot, right? YouTube is making money. LMS is, I don't think our management faculty is making money, that because only thing is because we got money from you all, so we had to give good service to the students. So that's where like basically it's going to be free, but others will be having their own models to make money. But from this, whatever the money you pay, it always goes to the internet and to the government. Is that clear? So this is the reality, right? If you can understand that, I hope you can understand the difference between internet and web, right? Because a lot of people think, web you can make money, right? But that's what you have to have a different model for that. But other than that, if from investment point of view, I would say being a cable operator, that in that huge satellite, sorry, submarine, not satellites, submarine cable map, right? Or like being an ISP, yes, you can. Okay, so that is what basically I want to tell you on that. And yeah, domain names we'll talk about later, right? Because the time is also coming up. First of all, like now I said, I can have 5 regional registries, that is called RIRs, right? That is for IP addresses. Then similarly, I can had another model, not regional registries, they call domain registries, right? So those domain registries are like .com domain registry, .org domain registry, .lk domain registry, .uk domain registry, what you name it, like hundreds of, maybe thousands of that now are there, right? So there can be lots of domain registries are there. So LK domain registry is another company or not-for-profit company. So you can go to, if you have never been, nic.lk, right? So then you can read more. So that's another company that those days we used to call, I think some Moratuwa graduates might be here. So we used to call University of Moratuwa. Actually, this is not related to University of Moratuwa at all. That is because one of the senior lecturers here that called Professor Gihan Dias, who is the CEO of this company. He's the one who bidded his proposal in some time back when he was doing his PhD in USA to ICANN. And he has obtained the domain of .lk. Right? Similarly, there are a lot of people who have got it. So these are not governments. By the way, that's why a lot of people think LK is owned by government of Sri Lanka. No, there's no way, right? Because ICANN don't want to make it more political or government, right? Or country based, right? So these are not-for-profit companies, right? They have director board, right? So they function. If they do not do well, right? Of course, they can remove their license and give it to someone else, right? But these are not governments. So .lk is not government owned. Let's say you are the education ministry. So I will call it MOE, right? Let's say one of you all are the minister now. You can say, I need MOE.lk, right? Because you have to apply for this and they will have to acknowledge, and they said, okay, we can do. If not, they say, no, we are giving only MOE.gov.lk, right? Because that is the policy we have. So then when they give you, they can't say, I want this, right? No, I want that. As long as they can entertain and get some money, that will be all right. But however, so these are not minister can do anything, right? Because this is a company, that organization, they are under ICANN. So actually they charge, so for their registration, probably they might have to pay something, but generally the money is between the domain registry and the user. Right? Again, now here ISPs are not coming into this picture. Earlier ISPs are coming in the previous picture. Here only the clients, customer straight away has to purchase from a domain name registry. So you can say, no, I'm not going to, like, if you're not giving, I am going moe.u, sorry, let's say edu, or you can say .com even, moe.com. Let's say it's the .com guy, this is here. They said, okay, I can give you 5,000 rupees per month, right, per year. So then he can get, then he won't get moe.lk, but he can get moe.com, right? So likewise, so this is .lk domain name registry, right? So for a year, you have to pay generally for a full domain 5,000 rupees, right? But if it is a 2-letter domain, that is like, let's say, ul whatever .lk, right? Whatever. So then it's 2 letters. You have to pay not this one, 25,000. If it is 3 letters, let's say mass like this .lk, right? So then you have to pay 10,000 like that. They have their own tariff. So then someone can say, if I want to get mas.com, I have to pay only 2,000 rupees, right? That's here you are paying 10,000 because that is .lk domain registry charges. This is .com domain registry charge. They are independent company. They have their own way of managing that, right? So that's where, like, you can see like different things have different rates. But whenever you do some business, let's say I don't know, Delma, right? And then it's going to get .lk, so they have more Sri Lankan, right? But sometimes I have seen like a lot of people are commenting on this tariff is a bit higher, but this is for 1 year, right? 5,000 from business point of view. I don't think that's a big amount, right? Or 25,000 even if you have 2 letters. But then if you can buy the same thing for 500, but always I would recommend, so going for like very generic kind of a domain name, right? Delma, right? It's good to go for the country code as well, right? Yeah, so this slide is just, okay, here only the TCP/IP I said earlier. This is all I have about TCP/IP, but it's a suite, right? Transmission control protocol, internet protocol. If someone is trying to see what is this TCP/IP, right? It's a suite of protocol that works together to connect to different types of computers. That's what, like here I said, common language, right? And upload, download, I think you hope you all know, right? From a server, right? So clean up here. So this can be a server. So whenever getting things, we call download. When you are putting to the server, it's upload, right? Okay, I think, yeah, any questions? I will stop here since we did about continuously 3 and 2 and 4. Yeah, now it's 11:15. So I will start from here because this is a new thing. This is just trying to talk about HTTP or web. Now only like we are going to start talking about web itself, right? Up to here, I was talking about internet. If you still have any internet doubts or anything, right, you want to ask, maybe I will answer, but I will not continue from here. I will start from here onwards from next week. I can give you some time for if you have any questions or doubts to ask.